Spray bars are a common feature in many production facilities. They consist of a series of nozzles arranged to produce a consistent spray across the length of the bar. Normally these bars are deployed on conveyor systems to provide cleaning, moistening, coating or lubricating sprays. Now, whilst the humble spray bar is a basic bit of hardware, there are certain design features that can greatly enhance its utility. This video explores these features and how, combined with good maintenance, a little upfront investment in a good quality spray bar can save significant amounts of time and money in the long run. So first, let's look at diagnosing and preventing spray problems with enhanced product features. The first feature is an integrated pressure gauge or flow meter right at the start of the spray bar. Now, it's likely that a pressure gauge will be present at some point between the pump and the spray bar, but having an additional gauge just before the spray bar is an incredibly useful diagnostic tool. If poor performance from the spray bar is noticed, there are many potential causes. If the pressure gauge right at the spray bar is showing a drop or a spike in pressure, then we can conclude that the problem is probably further down the fluid supply system. We can rule out problems with the bar or the nozzles, and so focus investigations and remedies on the fluid supply system itself. If a pressure gauge further down the fluid supply system, say near the pump, if this is used, this gives us less information. For example, a pressure reading near the pump that is within specifications probably rules out a pump fault, but the cause of the spray issue could be at any point between the gauge and the spray nozzle. This is why the gauge at the spray bar is incredibly useful and only adds a minimal cost to the actual bar. So the next feature is a flow tester, a specialist flow tester for the nozzles. An investment in a nozzle flow testing device will save huge amounts of time when diagnosing worn nozzles. This will in turn potentially save huge amounts of money, as we can identify and replace worn nozzles more quickly. Now, SC2 flow meter can be programmed with the expected nozzle parameters, and then within a few seconds will diagnose which nozzles are not operating within spec. Worn nozzles can be removed and replaced easily. The use of such specialist tools greatly speeds up the diagnostic process, and the very modest investment required to buy one of these along with your spray bar rapidly pays for itself. Let's look at a set of features that will minimize downtime. So number one, having a spare set of nozzles. Spray nozzles are generally not that expensive, but they are a wear part. And as such, all nozzles will eventually need to be replaced. The good news is that if they're not used, they can be stored for many years or even decades without any degradation in the product quality. They are, after all, just lumps of metal or plastic. So best practice for any spray bar setup is to have a complete set of spare nozzles. If any nozzle fails testing, they can be immediately replaced and the spare stock can then be replenished. So it needs to be remembered that in our catalogue there are 40,000 plus nozzle variants, and most manufacturers are the same. They cannot stock all those items. No distributor or manufacturer can stock all of those items. If your replacement nozzles need to be manufactured to order, this can be a lead time of 4 or 5 weeks sometimes. To guarantee that there are no delays in getting replacement nozzles onto your spray system, a spare set is essential. It doesn't matter too much if the spare set takes 4 weeks to restock, but if the one and only active set of nozzles takes this long, it could be a real issue. A spare set won't cost that much, and you'll need them eventually anyway because the original set of nozzles will eventually wear out. So buying spares up front just avoids any potential for production disruption. The next feature is self-aligning nozzles. Most nozzles will be threaded into a spray bar. With a flat fan nozzle, the orientation of the fan is very important to spray performance. But threads can become worn, and so the orientation of the fan nozzle may not be exact. Dovetail or bayonet connect nozzle systems allow not only for the very easy removal of spray tips, but they also guarantee the orientation of fan nozzles will be 100% correct. This can save a lot of time fiddling around, tightening threads to get the spray bar spot on. The final feature we'll look at here is built-in isolation valves. And sometimes this is forgotten and it's just madness to not have one of these. But a simple spray isolation valve means the bar can be removed and replaced easily. Without a valve, it can be messy or complicated to remove the whole bar for maintenance. Now, if a quick connect system is installed just after the valve, then even better. The whole bar can very easily be isolated and removed without fuss. So next, let's look at a set of features or practices to help maintain and prevent problems in spray bars in the first place. So the design features we've discussed above can be used to maximize spray bar functionality, minimize downtime, and speed up the diagnosis of spray problems. But even with all these features included, the spray bar still needs to be maintained properly. Here are our top tips for spray bar maintenance. Number one, have built-in filters. The type and size of filter required will depend on the spray nozzles being used and the application and the likely levels of particle contamination. The smaller the orifice of the nozzle, the higher the levels of filtration that will be required. Small orifice nozzles may require a level of filtration greater than for other applications using the same fluid supply. As such, if connected to a general use water supply, it may be necessary for additional filtration for the spray bar. A few specks of calcium deposit from hard water will probably not be an issue for many other applications around the factory, but it could lead to big problems with spray bar systems. It does not take much to clog a nozzle, so spray systems may well need additional filtration. A filter positioned just before spray bar that is of sufficiently fine mesh to protect the nozzle in the bar itself is therefore an excellent design feature that can save a huge amount of money. Number 2, regular inspection. Frequent and often is the mantra here. Even if there are no apparent quality problems, regularly check spray setups for nozzle blockage, wear and tear, and effective spray pattern. Keep a log of these parameters and watch for trends. Often by doing so, issues can be seen before quality problems actually occur. Once spotted, they can be rectified before this affects production. We would suggest weekly inspection for high use systems and perhaps monthly for low use. Number 3, regular cleaning and flushing. Again, this should be seen as a preventative measure rather than only being done when a problem occurs. Regular cleaning and flushing will prevent problems before they even occur. So use a soft brush or non-metallic tools to clean nozzles. For chemical residues, soak components in appropriate cleaning solutions. Avoid sharp objects that could deform or damage the nozzles, and schedule a system flush after every major use or fluid changeover. Doing these things will just help prevent problems occurring. And the key here is to do this regularly, even if you're not seeing any performance problems. It should just be part of the standard maintenance procedure. Finally, checking pressure and flows regularly. Small changes in pressure and flow rate may not affect production quality. They may not affect it that much, but if the problem persists or gets worse, then it certainly will. If pressure and flows are checked regularly and a record is kept, a trend can be spotted which may warrant investigation. This can help prevent problems before they even occur. So use pressure gauges to verify that the operating pressure matches the manufacturer's spec, monitor flow rates to detect clogs and leaks early, and install pressure regulators or filters if fluctuations are common. This problem is made far easier with the installed pressure gauges and if the spray bar flow meters are available, as discussed previously. In conclusion, making a modest investment in enhanced spray bar product features will greatly aid the diagnosis, monitoring, and remedy of performance issues. They will also help speed up and enhance the maintenance of such systems. Spray bars and nozzles are often viewed as very basic bits of kit and therefore neglected, but without proper maintenance and care, these basic bits of kit will not function properly, and then the entire, often very expensive fluid delivery system will not perform. The spray bar is, after all, the very last part of the system, so it needs to be cared for.